question is, why does this work so nicely? So the answer just really comes from that table, which we just established. Because if you look at, for example, if you want to do 8 times 5, then we just figured out this is reduced to 0.9 and 0.7, right? And in fact, this one is just labeled in a very weird way, not equally spaced. 8 is corresponding to not exactly the level 9 here, right? So you see that they're exactly at the same location, and then the 5 corresponds to the level 7 here. That's I already pre-labeled, based on that table. So that's why if I just label the number like this based on this table, then I can reduce the multiplication into the addition. So I just really transfer this one into this. Then I just back to that one to get the 40 here. Then similar thing for like 2 times 8. Remember the 2? 2 corresponds to 0.3. So that's exactly where I just labeled 2 for the level 3 because of the 0.3. And then the 8 is just similar here. And so you might think this is just not so useful because you already know the answer, right? I mean, how to multiply just one digit. But actually, 500 years ago, one guy just spent 20 years to just figure out this table was up to the 7 digit. So not only the 1 digit. So it took 20 years by one person. And then his work was much appreciated because once you get that kind of table, now you don't have to redo this kind of the calculation. You can just use this table for the reduction. So I just brought the 3-digit table, because the 7-digit table, so you need the shelf of the library, the encyclopedias. So 3 digits only you need 2 pages. Then you can easily calculate, right? Like how many volume of books you need. Like a 3 digit. Only 2 pages. So then the 4 digit you need is still just not much. 20 pages. It's a small book. Then the 5 digit you need a book now. 200 pages book. In the 6 digit, you need 2,000 pages book, so maybe you need a couple of books, right? And the 7 digit, you need 20,000 pages, so you need to read the volume of the encyclopedia, right? And that one is really published in the 500 years ago, and people use this one. So let's just do the Okay, now let's do this calculation. We have 3 digits. So you can still do it maybe by hand, but just imagine, do you want to do this by hand for the 7 digits times 7 digits? You probably don't want to do it, right? So if you're okay with the approximate answer, now you can use this table, much quicker to get the answer. So what you have to do is pick up this table and then look at the size for 9.38 now, corresponding size for this. Then you can get this one by looking at the second page. You just scan the table. Then you look at the 9.3, and then you look at the 8, and then just read off what's crossing. So that's what the 9.38. You get 0.972. And then do the same thing for 7.42.
0.872.
0.8704. Then this is not so bad, right? Compared to this one. Okay? So, well, you can use calculator today, but no. you can easily do this by hand, right? Because this is only addition. 1 point. So now you use the table backwards now. Okay? So scan the table, and then in the table, if you find 1.8426 somewhere, then you get the answer here. Okay? But can you find this? No, why not? Yeah, because this table only from the 1 to 10, right? So it's only 0 to 1. So of course you can find the 1 point. But here's a trick. This case you can split. Okay? So you can split 1 point. Something. As a 1 plus rest. Now you can find this one, right? Inside the table. Okay? So in the table, you just scan the table. Then now you just go backwards to read of the original value, okay? Corresponding to this. 6.96, right? And then, remember, this corresponds to 10, right? Then remember this is times. So this way, this one, you don't need a calculator, okay? Times 10, so you just move the decimal point to the 1. Then you get 69.6. Okay? So this is how you get the approximate answer for original calculation. And then, well, if you have a calculator, let's just cheat. But what's the actual value of that? What's the exact value of this? So this is the exact value. So that's not bad at all, right? It's very close here. Okay? And then this even works much better for the division. No? Do you want to do this by hand? Yes. If you remember how you got the size for the 0.5 by doing this. Remember? 5 is 10 over 2. 10 divided by 2, right? And then you got this x to be 1 minus 0.3. In other words, you just reverse this. Now you can easily understand that the division is now reduced to the subtraction. Okay? So that's why to do this now, okay, I think now you don't want to do this by hand, right? The division is much harder, okay? But this is not bad at all. Okay? You can just do it by hand very easily. Okay. Then this time, you may not be able to see the exact value on the table, but what's the closest one? 1.26 or 27, right? Okay. So probably you can expect the answer to be 1.26 something. Okay. Then again, let's cheat. Let's cheat using your nice calculator. Okay. in the 21st century. 1.26415094. Exact answer is 1.26 or something. So it's not bad at all, right? Okay. So that's how you get it. And so now the question is, you probably realize, right? What I'm talking about here.
You're talking about base 10 system, logarithm?
Yeah, that's exactly the logarithm, right? Okay. So in my opinion, I don't know, some of you maybe teach, right? Maybe teach in high school, you know. This is how really the log should be introduced. Because if you just simply define the log, you know this formula, right? So if you force the student to memorize all this formula, what is this for? You know? You know this famous formula, right? Yeah. So maybe they could be good at just doing this one, but what is this useful for? This really came from this kind of motivation, okay? So you really want to reduce the difficult multiplication and division into the easier addition and subtraction. Okay? And but nowadays, because of this technology, of course you can just get any answer very quickly, right? So, but honestly, this was still taught in the high school in the 70s. I studied this in the high school, okay? But no, not anymore because of this. Okay? But, nowadays, you can get a nice value, log 2, just by putting this, or even like a 3-digit. What is this value? If you look at the 2.00, what's cross number? Remember what I got? I got a minute ago just a point only 3, right? Why you have this extra thing? But where this 10 comes from? Remember what I did? I raised 2 10 times and I got what? 24, right? Then what did I do this junk? I dropped, right? That's exactly I dropped this 10, okay? If I don't drop this, and if I work for another 20 years, then I can come up with this one. Okay? So, okay.